Okay, everybody, so welcome to Day 3 Notes, Special Segments and Triangles. Got 5 different vocab words for us to investigate today. First one is a mid-segment, which is a line segment that connects the midpoints of two sides of a triangle and is parallel to the third side. So for instance, here in our picture, when we take a look at it, I've got like a midpoint B and a midpoint A, shown by having equal sides on either side of those. The mid segment would be like what I'm drawing here in red, connecting those two midpoints. And it's going to be parallel to the third side, and it's going to be half as big. So like our formula here could be that AB is half of ON. The other thing that you'll notice is like if C is the midpoint of ON, AB is going to be the same size as OC and CN. Another thing you could say, if AB is half of ON, then if I take ON and that would be 2 ABs. So 2 of those red ones gives me the whole ON. If you want to write about how you'll remember, one way that I remember is that a mid-segment connects mid-points. Seeing mid in both of them kind of helps me. I'll look at 2 example problems with you after we write down just, again, that AB is going to be parallel to ON and half as big. All right, so if I've got these 2 pictures, first of all, I can look at it and see, oh, this is a midpoint because it's the same on both sides. This is a midpoint because that segment's the same on both sides. So that means that x is going to be half as big as 34, or 34 divided by 2, which is 17. Done. Again, not very hard math, you just have to be able to look at something and know what problem to set up. So second one, I see a midpoint, half of one side, another midpoint, half of the other side. So that means that x minus 8 is going to be equal to half of 35, or 35 divided by 2. I set it up, I'm going to leave it to you to solve. You should get a decimal on that one. Alrighty, next vocab word is a perpendicular bisector. We've seen this one before, but just as a reminder, a perpendicular bisector is a line segment that goes through the midpoint of one side of a triangle at a 90-degree angle. So how you can remember, I think about how perpendicular means 90 degrees and bisector means cutting in half. Here's a nice lovely picture. You'll notice that a perpendicular bisector, which is this line PM, when it cuts the AB in half and makes a 90-degree angle, we also get 2 congruent triangles by side, angle, side. So PB and AP will be the same as well. And that's going to help us solve our 2 questions down here. I'm going to do one of them, leave the other to you. When I see, oh, perpendicular bisector, so it made a 90-degree and it cut these things in half. By side, angle, side, I could tell that these 2 triangles are congruent, and therefore 3n minus 1 will be the same size as 5n minus 7. Combine some like terms, and I'd get 2n equals 6, so n equals 3. You try this one over here. 3 more. Next one is a median. So I kind of think about like the median when you're driving, the median of the road. A median in geometry is a line segment that extends from one vertex of a triangle to the midpoint of the opposite side. So a median essentially divides this opposite side into 2 equal pieces. And I like to think about how a median divides the road into 2 equal lanes. So let's consider this example. First of all, I see a line segment that comes out of an angle, and it's dividing the opposite sides into two equal pieces, meaning that x plus 4 had better be the exact same size as 3x minus 12. And if I subtract x from both sides, I get 2x. If I add 12 to both sides, I get 4 plus 12, which is 16. So x is 8. Again, not super hard math, just got to know the vocab words so that you'll know how to set something up. Second to last one, I have an altitude. An altitude is a line segment that extends from one vertex or point of a triangle and makes a 90-degree angle with the opposite side. And what the altitude looks like will be different depending on what kind of triangle you have. So for an acute triangle, the altitude is inside the triangle. An obtuse triangle, if I pick a point and go straight down to make 90 degrees with the opposite side, that altitude ends up being outside the triangle. And then for a right triangle, the altitude actually is one of the sides of the triangle. Nifty. How I remember this, an altitude, I think about like height, like the altitude of a mountain. So when you've got like your mountain and you need to measure how tall it is, you don't measure like down the side of it. You measure straight down. So I think of mountains and how you measure height to remember what an altitude is. Here's our example. It says find BC if AD is an altitude of ABC. Whoa. All right, so I read the word altitude and I think about measuring straight down, making a 90-degree angle. So this 3x plus 9 has got to be 90 degrees. So that's where I'll start. 3x plus 9, if I've got an altitude, 90 degrees. Subtract 9 from both sides. Divide by 3. Radical. All right, but I didn't answer the question yet. I found x, but I still need to figure out how long BC is. And BC is this entire distance. I know this little section right here is 27 because x is 27. To figure out how long DC is, I'm going to get my trusty calculator out. I'll do 2 times, not x, but 27. And then minus 7 is 47. So BD is 27, DC is 47, and if I want to find BC, I'll just add those two together. So 47 plus 27, drum roll, 74. And now I'm done. Final question, or sorry, final vocab word, one we've seen before, an angle bisector, is a line segment that divides an angle into two equal pieces. Again, how I remember this one, bisector means cutting things in half. So if it's an angle bisector, it's cutting an angle in half. Here's a nice lovely picture of one. And finally, I see my angle bisector, BD. So if BD is an angle bisector, that means that 2x equals 84. So x equals 42. And I'm done. See you in class.